And before we move on to the next lecture, I would like to show you some examples or some interactive tools online. For example, you can go to logic.ly and you can come to this website and have fun with logic gates. So I'm gonna just mm, close this window and take some gates. So I have AND gate, and I'm gonna take two switches. So that's a switch, and that's another switch, and I'm gonna connect them to this AND gate, which is just like the AND gate that we saw earlier. And I'm gonna put a bulb here and connect it to the output. So we have those are the inputs. So let's say this is the A, this is B, and then if A and B are closed, we have on. So only and only if A and B are closed, and we have output. So I'm going to select everything. I'm going to click here on this generate truth table, and we have input 1, input 2, 0, 0, true, true, or 0, 0, 1, 1, 0, 1, 0, 1, and this is the output 0, 0, 0, 1. So only and only if both of the input and output are true, we get an output. So let me just remove the AND gate, and this time I'm going to put an OR gate, and we're going to connect this one to this one, and then here. So OR gate will work if A or B is true, or both of them are true. The only way that we will get an off is when both of them are off. So I'm going to select all, generate the truth table, and then you can see the truth table. It's false only if both of them are false. So I'm going to delete it. I'm going to put a XOR gate, and XOR gate, if you remember, we said the bulb will turn on if one of them, either A or B, is on. So both of them are true off, we don't get anything. But if A is true, but if the other one is true, no, it doesn't work. So only if one of them is true. So that's the XOR gate. So we go to the NOT gate. NOT gate, so we will have exactly the opposite of the input. So we don't need this one. So like this. So if we do like this, so it's on, but the bulb is exactly the opposite of the input. With these inputs, we can make some more complicated uh, circuits. For example, we can create some circuits, so we can create a lot of gates, this gate, and we can connect it with another gate and another gate and another gate, let's say XOR, and they will produce what we call an electronic circuit. So we can even connect this one if I go crazy, and we can have fun. We can really have fun with we can connect this to this. We can do some crazy. I'm just goofing here. I don't know what I'm doing, but I'm just saying that with those kind of circuits, you can have some pretty advanced circuits. I'm almost going to make a flip-flop here, and you can experiment here. What can happen if you take two switches here, for example? I'm going to connect this one here, this one here, and this one to this one just for fun and see can I do this. No, let's make another switch here and another switch here and see what happens. I have no clue what can happen really, so because we will never have a if I just switch this one, yeah, and then I just created a, I don't know what I will call this switch, this circuit as a Nassim circuit, okay, let's say. And once this circuit is usable, and we will use it in many times, we can create a circuit. So we have here 4 inputs and 1 output. So instead of doing this, we can do exactly the same thing. And here you have 3 inputs and 2 outputs. And this is called, actually, this is a circuit that is called a flip-flop, the SR flip-flop. SR flip-flop is just like the circuit that we were doing before, and it has some truth table. And I don't want to go into too much details, but those are very important for the logic of the microprocessor and controller and microcontrollers and everything that is related to circuit designs in electronics. More on that you can study about logic gates and circuit designs, but this is not really the core of our courses here. I just wanted to introduce you to the logic gates and circuit designs in general. And if you want to learn more, you can Google circuit design or logic gates, and you will have a lot of fun. Okay, so just type logic gates design online. And again, this is not a topic of our course here. This is just a very quick introduction to logic gates. And let's move on to the next lesson, which is binary code. Thank you.